So example number 1. A 100 by 100 by 10 millimeter angle is to be welded to a gusset plate. The angle carries a load of 200 kilonewton applied along its centroidal axis, which is 28.7 millimeter above. The short leg is as shown in figure 21.24. So use an 8 millimeter fillet weld with a minimum tensile strength. F sub u is equal to 483.33 megapascal. So first, which of the following gives the length of the transverse fillet weld along the edge of the angle in order to avoid eccentricity of loading? So next, which of the following gives the length of side fillet weld required at the heel? And lastly, which of the following gives the length of side fillet weld required at the toe? So first is the length of side fillet weld along the edge of the angle. So to avoid eccentricity of loading, the length of fillet weld at the edge of the angle must be equal to the length sub 3, which is L sub 3 is equal to 2 multiplied by 28.7, which is the L sub 2, Y sub 2 rather. So our L sub 3 is equal to 47.4 millimeter. So next is the length of side fillet weld at the heel. So F sub 3 is equal to 0.707 times T multiplied by L sub 3 times 0.3 multiplied by F sub u. So our F sub 3 is equal to 0.707 multiplied by 8 times 57.4, which is the value of L sub 3, times 0.3 times 483.33, which is the value of F sub u. So our F sub 3 now is equal to 47,075. So in order for us to find the value of L sub 1, we have first the summation of M sub moment A is equal to 0. So we have 200,000 minus 47,075, which is the value of F sub 3, multiplied by 71.3, which is the value of Y sub 1, is equal to F sub 1 times 100, which is the total of adding Y sub 1 and Y sub 2. So our F sub 1 now is equal to 109,036 Newton. So now to find the L sub 1, we have a formula of F sub 1, which is 0.707 times T times L sub 1 times 0.3 times F sub u. So substituting F sub 1 is equal to 109,036 is equal to 0.7707 times 8 times L sub 1 times 0.3 times 483.33. So we have now the value of L sub 1, which is 132.95 millimeter, which is the length of welded at the heel. So next is the length of weld at the toe. So we have summation of moment B is equal to 0. So F sub 2 times 100 is equal to 200,000 minus 47,075 multiplied by 28.7, which is the value of Y sub 2. So our F sub 2 is equal to 43,889 Newton. So to find the value of L sub 2, we have the formula of F sub 2, which is equal to 0.707 times T times L sub 2 times 0.3 times F sub u. So the value of F sub 2, which is equal to 43,889, is equal to 0.707 times 8 times L sub 2 times 0.3 times 483.33. So we have now the value of L sub 2, which is equal to 53.52 millimeter, the length of weld at the heel. So to check, we have the total L required, which is 200 over 0.707 multiplied by 8 multiplied by 0.3 and multiplied by 483.33, which is equal to 243.87 millimeter. So in order for us to know if the total required L required is correct, we have L is equal to L sub 1 plus L sub 2 plus L sub 3, which the value of L sub 1 is equal to 132.95. For L sub 2 we have 53.52, and for L sub 3 we have 57.4, so a total of 243.87 millimeter. And as you can see, it is okay. So for the example number 2, we have a 100 by 100 by 10 millimeter angle is to be welded to a gusset plate as shown in the figure. The angle carries a load of 195 kilonewton applied along its centroidal axis. The maximum size of fillet wheel that can be used is 10 millimeter and the allowable shear stress of 94 megapascal. So determine the length of the side fillet welds if a transverse fillet weld is added at the end of the angle. So we have here the B, C, and A, which are the lengths, and 71 millimeter and 29 millimeter, which 71 millimeter is for Y sub 1 and 29 millimeter for Y sub 2, and 185 kilonewton for P. So we have a formula of P is equal to F sub V multiplied by 0.707 times T times L, which the value of P is equal to 195,000, which is the load, and 94 for the allowable shear stress, multiplied by 0.707 times 10 multiplied by the length. So we have the length is equal to 293 millimeter. So for C, which is the length sub 3, we have 29, which is the value of Y sub 2 multiplied by 2 is equal to 58 millimeter. So P sub 1 plus B sub 2 plus P sub 3 is equal to 195 kilonewton. So for P sub 2, we have 94 multiplied by 0.707 times 10 times 58, which is the value of C. So we have now the value of P sub 2 is equal to 38,545.64 Newton, or 38.545 kilonewton. So for us to find the P sub 1, we have the summation of P sub 3 is equal to 0. So P sub 1 multiplied by 100 is equal to 195 times the value of Y sub 2, which is 29, minus P sub 2 multiplied by 29, which the value of P sub 2 is equal to 38.545. So we have now the value of P sub 1 is equal to 45.372 kilonewton, or 45,372 Newton. So for us to find the length sub 1 or A, so we have a formula of P sub 1 is equal to F sub V multiplied by 0.707 times T times the length. So for P sub 1, we have 45,372 is equal to 94 multiplied by 0.707 times 10 times A. So we have now the value of A is equal to 68 millimeter. So next, for us to find the value of P sub 3, we have the summation of moment P sub 1 is equal to 0. So P sub 3 multiplied by 100 is equal to 195 times 7 to 1, which is the value of Y sub 1, minus 38.545 times 7 to 1. So our P sub 3 is equal to 111.083 kilonewton or 111,083 newton. So now for us to find the L sub 2 or B, we have a formula of P sub 1 is equal to F sub V multiplied by 0.707 times T times L. So for P sub 1, we have 111,083 is equal to 94 multiplied by 0.707 times 10 times B. So the value of B is equal to 167 millimeter. So for us to check if the lengths are correct, so we have L is equal to L sub 1 plus L sub 2 plus L sub 3, which the value of A or L sub 1 is 68, for B 167, for C we have 58, a total length of 293 millimeter, which is okay since it is the same in here.